Ready. Ready. Ready.
Hello, welcome to Enlightning. Hey, thanks for sharing your time and attention with us today. Today we have Fog Dong on as our guest who's going to teach us about KubeVela. She's a maintainer on the project. Fog, tell us about yourself.
Sure. First, thanks for the invitation. My name is Fog Dong. I'm currently a senior engineer at Alibaba Cloud and also a maintainer of KubeVela and a CNCF ambassador, which Whitney is also a CNCF ambassador. I'm really glad that we can have this chance to talk with each other. Yeah, I have been, actively involved in the open source community and particularly in the cloud native DevOps field. Yeah.
That's amazing. So happy to have you here. And we have lots of guests saying, lots of folks in chat saying hello. Thank you,
Hi.
Lisa, for coming. Hi. Simon's here. Hi, Simon. Thanks so much for coming. And we have Stro the Dev here. Thank you for being here. So I didn't know about the CNCF ambassador thing. I kind of was vaguely aware that some people I looked up to were CNCF ambassadors, but I didn't really understand even what it was exactly when I applied for it. What made you think that you wanted to apply to be a CNCF ambassador?
I think, being an ambassador, because we are all both chosen. So I think it means that we can just, doing what we are doing right now, have some, propagate the CNCF projects, write blogs, the webinar, such things. And it's pretty exciting because, we are both involved in the community, and it's great to have this reward and the power to share more with the community.
Yeah. It's nice to have that validation, I think, that we're doing things right. And also, I like being like a positive like woman role model, to be like, there's so few women in the cloud native space. So having a little bit of extra attention to be like, hey, women are here, we're here. When you're talking about the ops person, don't say ops guy. Like, we're here too. Ops people, ops folks. Yeah. So I think that's
really
important.
Amazing. When I go out to have some speech, sometimes the audience will think that I'm like a product manager, but not a developer.
Oh,
Project.
yeah. They assume you're A product manager, interesting, or marketing or something. Yeah.
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 Sad. Just me and a little bit sad.
It's true. Yeah, yeah. Because yeah, I do my best in life in general not to make assumptions about any people ever or really anything, which I think is part of what makes us good in tech. You shouldn't make assumptions about what something is going to do, or but it works with people too. Yeah. So, yeah, so we have another hello in chat. Fabrico's here from Argentina. That's so cool. Fog,
Hi.
hey, Fog is here from Beijing. What time is it where you are right now?
It's 11 p.m.
11 p.m.
late, late night.
When we scheduled the show, you told me you're a night owl, so I don't feel too guilty. Um,
That's okay. I'm a late night kind of person, so that's cool.
Yeah. I think it's so, I mean, I just think it's so amazing that we have like Fabrico here from Argentina, and then you're here from Beijing, and then I'm here from Texas, and we're all just hanging out in real time. Like it's such an amazing world. I guess it's cloud native technologies that power a lot of this experience, huh?
Yeah.
Excellent. Well, I'm going to start moving behind the board. What I would love to hear from everyone in chat, I would love to know, have y'all used KubeVela before? Have you touched it? If so, what's your experience been like? And if not, like, what are you hoping to learn from this show today? We'll definitely get to that. Or if you have any questions right off the bat for Fog or for me, please do ask them. And throughout the show, be liberal with your questions. We're happy to chat. And then Fog, from you, while I move behind the board, I would love to hear about your career path and how you came to be a maintainer on an open source project and how you got into open source in general.
Okay, cool.
Cool.
I'm gonna introduce right now, and you are going to the board.
Yeah, I'm going to go behind the board. First, I'm going to put a link into chat about the KubeVela docs in case anyone wants to get into those. And now I'm going to go behind the board while you tell me about your life choices,
Sorry.
all the choices
Yeah.
you made in your life to lead you to this moment right here.
Cool. Actually, after my graduation,
Mhm.
I went to a startup that the founders of it is previously worked at Google, working about Borg. So they just set up this startup company to build something on Kubernetes. And that's the first time I get involved in cloud native. And then I know the power of the community, and I started as a contributor to some cloud native projects like Tacton. And then that company was acquired by ByteDance. And then I left the company and went to Alibaba Cloud. And because I had some previous experience, contributing to the open source projects, so I get the job at Alibaba Cloud, which I'm really lucky to have this chance, because I can fully concentrate on cloud native and, contributing to the KubeVela project and become the maintainer of it. So that's really exciting. Yeah.
That's awesome. So being a maintainer is part of your job?
Yeah, sort of, because I still need to, focus on some commercial product that based on our open source project
Okay.
in the company.
And that's pretty common. Yes, a pretty common pattern for companies. Oh, can you hear me?
Running a open source project. That's pretty common because you need to you need some commercialization to support that open source.
Yeah. We have Scott here. Hi, Scott. Thanks so much for coming. Scott's visiting us from Israel. Scott was a guest on the show recently teaching about Carvel Cap Controller. I'm almost ready here. So did you feel like when you first started contributing, did you feel welcome? Was it scary for you, or did you feel like people were like super excited to have you? How was it?
I think it's like I don't see some unwelcoming or like we are really welcome you here to contribute. It's just like normal things. And I think the biggest problem is the language gap because you need to chat with your unfamiliar language with some
Uh-huh.
maintainers from other countries. And
Yeah.
will have some gap between them. But but
And
but I think the code is a unified language, so basically that's fine.
that's great. We have some more hellos. Hello from Justin's here, eventually.
Hi.
And hi, Findle. Everybody's here. So we got people here from New York now. Findle, remind me, remind me what country you're in, Findle. Um, this is a global experience. I
Yeah.
actually wanted to do an enlightening about a technology called Dragonfly that's mostly maintained. It's a very popular in China, but not popular here. And
Not possible here.
yeah, well, not
Okay.
that I know of. I don't know. My very
Okay.
limited worldview. It's anecdotal again. But I wasn't.
Excellent. Yeah.
Yeah. Gaius wanted to be my guest, and he's so nice, but he just didn't feel comfortable. Even though I said I don't mind at all how much we need to repeat things, but he didn't feel comfortable enough with his English to be able to be a guest for that show. So therefore, that's why I haven't done an enlightening episode about that technology yet. But yeah.
Yeah.
So it's privileged of me that everyone speaks English, right? It's lucky. I got lucky with where I was born. Findle's in Sweden, so Findle's here from Sweden,
Hi.
and
It's really amazing that we have people from different countries.
yeah, and Linus is here. Hi, hello.
Hi.
We have so many. Awesome, awesome, cool. All right, let's get started. So the way I love to start episodes is I want to know, oh, so many questions on this one. But to start, Fog, will you paint me a picture of what things were like before KubeVela existed that caused KubeVela to get created? Like what were the problems that needed to be solved?
Yeah, so before KubeVela, it's pretty common because, the fast growing of the cloud native infrastructure. So
Ah,
our users has, they have to deal with more and more capabilities to deploy applications such as like high availability and security. But the underlying infrastructure also expose an increased number of complexity directly to the application developers.
okay.
You
So,
are application developers, you need to know a lot of knowledges like the underlying infrastructure. Do you want to choose,
uh-huh.
like some cloud or private cloud or DNS or a lot of concepts? But
Yeah.
for the application developer, they actually just want to deploy the application. They don't want to, understand the underlying infrastructure because it can be too complicated.
Okay. So what you're saying, what I'm hearing is, tell me more about like the fast growing part of cloud native space. So are you saying like a company knows they want to get into cloud, they like buy their first managed Kubernetes on one cluster, and then all of a sudden poof, they need all of these other things and they're just adding them on with before is that like what do you mean by the fast growing nature of it?
For example, if a company want to get in the cloud native, he might first, uh, apply have a Kubernetes cluster, and
Uh-huh.
then he have to have one guy that is
Or
familiar
girl.
with Kubernetes, which
Okay.
in a small company they might just have the application developers who know little
Mm-hmm.
about their underlying infrastructure, and their demand may be very easy, just to apply that application
Mm-hmm.
in. And it's better if they can leverage the power of cloud native but know little about that. Otherwise,
So,
they have to, have a team that is what we call DevOps team in that company.
okay. So a lot of operational responsibilities falling on the application developer. Yeah.
Yeah.
And then you already started to kind of mention SIB. Um, let's write some examples of those things. Like you said, DNS, for example.
What? The experts.
Oh, we have a lot of friends in the chat right now. So we have hello, thanks for coming.
Hi.
We have hi, yay, so many so many great friends. Hello. Yay. Okay. Oh yeah, this is wonderful. I appreciate all y'all for being here. That's my Texas, all y'all. So a lot of operational responsibilities
Responsibility.
is falling on application developers. So this is stuff like worrying about like ingress kind of stuff, like DNS. You said. What other things might fall on them?
And to just to make things more clear, like the ingress, there's some API break change in different Kubernetes version. So if you
Okay.
just want to have the capability of ingress, you need to make
Uh-huh.
sure that they match the different versions of the underlying clusters, right?
Mm.
So it's a very specific case
Mm-hmm.
that shows that if you want to leverage the capability of Kubernetes, you have
Mm-hmm.
to be an expert. Otherwise, you
Okay.
not deal with that.
Yeah. Um, yeah, backing service. Yeah. All kinds of things. Let's see. And not, yeah. Okay. So we have to worry
And
about backing services. We have to worry about the way traffic's routed. As an application developer, you don't want to think about any of these things. You just want to think about programming your application. Right, Findle? I know Findle's an application developer. That's why I'm calling Findle out.
that's
Uh,
cool.
Nick, the first one. Hello. Thanks for being here, friend.
Hi.
All right. So that's what's happening. That's the problem space. And honestly, Fong, this is a problem space I've heard about many times now from many different technologies. So I'm
Yeah.
very interested in the KubeVela take. Are you able to hear me?
Yeah, but I
Okay.
cannot see your video.
Yeah, it just left me. Let's see if I think you're gonna see my face trying to troubleshoot it right now. Let me try just unplugging it and plugging back in. And if that doesn't work, I'll just restart the browser. And if that doesn't work, I'll restart the computer. It's like IT hour with Whitney. I've
Oh, I also saw a friend that he said, "Hi, here's Zhiqiang from Hangzhou," and he's actually a maintainer of Chaos Mesh.
Oh, cool. Welcome. Okay, so I'm going to restart my browser. I'll be right back.
Okay. Hi, everyone. We need to wait for a second for Whitney. Hi, I'm good. Thank you. It's pretty late in Hangzhou. Hi, Nick. Oh, hi, Lisa. Lisa's asking that where I'm living. I'm living in Hangzhou, which is a city in Zhejiang province in China and near to Shanghai. Maybe you are more familiar with Shanghai. Yeah, we're just chatting. Hi, Winnie.
Hello. Thanks for keeping it going, y'all. It was just a browser restart, So, okay, so we're just saying that this is a common problem, and it leads me to a question too, which is I'm hearing a lot about. I feel like it's really popular right now to talk about platform engineering, Is this in that same family of platform solutions?
Yeah, I think the another thing that I want to talk about the things before KubeVela is that there
Okay.
might be some gap between the DevOps team and the application developer, because
Okay.
in different in different company, the DevOps team need to handle the similar things but slightly different because the policy is different in companies. So uh, we try to in KubeVela, we're trying to find a way with some abstraction layer to unify, to with this abstraction to let DevOps team to build their own platform. So and beside that, the users can have a unified experience. So they might just need to care about the application.
So the goal is for the application developer to only care about the application.
Yeah,
And the DevOps team wants to supply that experience, right? That's the goal of the DevOps team specifically, is to give that experience to the application team.
yeah.
And then
And
when you say there's a gap, what do you mean there?
because if there's no abstraction, the developers need to know some underlying infrastructure or
Oh,
some
okay.
like different concepts, because we all call it application, but the concepts may be a little different in different companies
Yeah,
because of the
that makes
business
sense.
logic and policies and such things.
So the goal of the DevOps team is for the app developers to only have to worry about their own application.
Yeah.
Yeah. So I'm right, for the app devs to develop. Oops. Excellent. All right. So that's before KubeVela. So KubeVela swoops into the scene to save the day.
Yeah. And KubeVela is actually the implementation of OAM model, the open application model. So before we get into that space, we actually, the Microsoft and Alibaba, they joined together to have this model in the community. Yeah, open application
OAM,
model. Yeah,
open application model.
yeah.
Okay, so I don't want to write this. OAM. OAM. So this is we did an episode recently on dev file, which aims to be a specification for how a development environment is defined. So
Yeah.
this feels like it's meant to be a specification for how an application should be defined. Is that correct?
Exactly.
Okay. Open application model. That makes a lot of sense because there's no such abstraction in Kubernetes. You're just dealing
Yeah.
with separate resources, and it really makes sense to have a way to be able to group them into and say, this is all the things related to this particular application. So that makes sense. Open
Yeah,
application.
we want this to be a standard, but there's a lot of way to do it. There's still a long way to do it.
Okay, and you said it's Alibaba and Microsoft?
Yeah, and when Microsoft joined, post that in 2020, I guess.
Oh, it's been around. Cool. So I'd like to write a little bit more of a definition on the board. So it's kind of implied open application model. So a standardization for how an application is represented in Kubernetes. Is that correct?
Oh, and not exactly, because it
Okay.
is a specification for
Specification.
application, but the application did not, have to apply it in the Kubernetes. It can be some
Ah.
bare machines or something others. It is just a specification. It can be applied to anywhere.
Okay.
Actually, in our community, the KubeVela is the implementation on Kubernetes, but in our community, some of our users use it to apply their applications in both Kubernetes and virtual machines. Yeah.
So they use OAM to do Kubernetes and virtual machines, but when they do OAM on Kubernetes, that's where KubeVela comes in. But to apply their OAM application on virtual machines, do they use KubeVela for that too?
They actually do some development, so they use KubeVela to apply both in Kubernetes and virtual machine, but they do it on their own company.
Not necessarily Kubernetes.
Yeah.
Cool.
Okay, so maybe first talk about the.
I have a quick question. What if Kubernetes, what if you want to define a Kubernetes, like your application is meant to run on Kubernetes? Can you define your Kubernetes resources in the OAM? Yes.
Yeah.
Okay.
Actually, we to answer this question, maybe it's better to explain the OEM model.
Okay. Great.
So in this OEM model, we have basically it is basically an application that combines components and trees, and the components is actually what we are used to model the workloads of the application. And the trees are used to attach extra capabilities to that components. Like, for example, in Kubernetes scenario, the components can be a deployment, and the tree can be its service and ingress.
Okay. So an OAM, you said it's an application? The OAM itself is an application, or you meant the OAM is just I'm picturing as text, like a document, maybe a YAML file. Is it?
Yeah, you can say it as a YAML file.
It's a YAML file? Okay. I'm going to say YAML specification. Okay. And so that YAML file is made up of components and traits.
Yeah.
So what's a component again, please?
It is a workload.
A workload. So your example is deployment in Kubernetes space.
Yeah.
So this represents a workload. For example, a deployment. I'll change my color. Cool. And then a trait would be a child of a component, right? Like a trait points at a component. Is that correct?
Attached to this component.
Okay.
And actually, though I use deployment and service as an example, because actually a lot of our KubeVela users, they may know little about Kubernetes. So in our scenarios, we will wrap like deployment as a web service, because it's much more easier for people who know little about Kubernetes to understand. And the service and ingress, we will just wrap it as gateway. So it is this component has a type, and tree also has a type. The type is just a type, and it can point to some implementation that like you can render the components, for example, a deployment to render the results. But in that model, you just need to specify the component name and type, so that the developers, they do not know the underlying infrastructure. They just need to know the concepts in application.
So there are many possible types for a component, right?
Yeah.
Cool. I'm just writing many types. And then a trait represents, what does it represent exactly? Will you tell me the words again?
Some extra capability that attaches to the component,
Okay.
like service and maybe replicas of the
Okay.
yeah. In Kubernetes deployment has replica in its spec, but in
Uh-huh.
OAM, the replica can be a trait because people do not need to know the whole spec of deployment. They just need to,
Mm-hmm.
maybe in our scenario, the component user only have to specify the image of the component, and he can
Or
bind
she.
he can bind several, traits to that component, like service, replicas, storage, such things. So we just
Okay.
separate it.
That makes sense. So there are many types of components, and then once you choose a component type, I imagine that will have its own
Yeah,
possible traits.
yeah.
Cool. I wonder if I should capture that. Excellent. So an OAM is a YAML file, so you could declaratively define your application. And within that YAML file, you use components to represent a workload, but there are lots of different ways, lots of different types you can use to do that.
Yeah.
And then you further define your workload by adding traits to a component. And the amount of the traits that are available to you are dependent on the type of component that you choose.
Yeah.
Great.
And KubeVela is actually the official implementation on Kubernetes. And based on that model, you can, implement your own way to how to use this model.
Okay. I love it. You're doing a great job. So
Thank
okay, so now we're to the point we're going to say KubeVela is. We're going to write our definition.
Okay.
So KubeVela is the official Kubernetes implementation of the OAM.
Yeah.
Okay.
Is it better to specify KubeVela as a modern application platform in case people did not know the OEM concept?
Okay. Yes. Yeah, that sounds good. Okay, I like that. Good idea. KubeVela is a modern application platform that is, or just maybe and the official implementation of the OAM on Kubernetes.
Cool.
Who declares what's official?
And the OEM team.
Cool. Is the OAM spec open source?
Yeah. And the KubeVela was original, incubated in the OEM organize and moved to a separate organize called KubeVela later.
So KubeVela was part of the OAM, but now they've been separated.
Yeah.
Cool. Excellent. All right, show's over. We did it. Just kidding.
Okay, I'm getting off.
Just kidding. You're not allowed to leave until this board's full. Findle's saying Findle.
Hi.
Hi Findle. Findle streams too, and sometimes I get to visit Findle's stream, and Findle has a wonderful cat named Zelda. So Zelda has their own emote now on Twitch, which which I'll be using a lot. Thank you.
That's lovely.
Let me disrupt your learning to talk about a cat emoji. Okay, let's this is wonderful. Okay, I already have like a much clearer picture. So let's talk. What else would you like to teach us about KubeVela?
Okay, so I can first, point something like if you want to apply a deployment together with service and ingress in your Kubernetes, you may need to write like 3 or more YAMLs to different resources. And in KubeVela, because it is application-centric, so you just need to write your application. It may compose with a component that points to deployment, and together with that component, you have like 2 traits point to service and ingress. So you just need to write one YAML file. That is your application.
That makes a lot of sense. Do you think, based on what you plan on telling me for the rest, do you think it would be wise to like have a list of benefits and like one benefit is application centric, or we can just, yeah, okay. So great. So benefits, and then we have our first one, and that is application centric. And by that, so by that you mean one YAML for an entire application as opposed to having to worry about a ton of different Kubernetes resources.
Yeah.
Right.
So, yeah.
So here's the thing I'm thinking.
Yeah.
Technically that's not necessarily in and of itself a benefit, because you could just have one YAML that just has all the different fields that, like a YAML can be any length. So this still could be a really complex experience for an application developer. So how is that addressed? A simpler YAML, one simplified YAML for an entire application? Or
it's not just a simplifier. It also, covers all the underlying infrastructure to that YAML, because we have this type in components and trait, right? So the type is an abstraction layer. So for the developers, application developers, they just need to choose the right type. And we have some we already have some official types in our community, but for the if you want to customize your own type, that is the DevOps team that they can customize their type, because we use a language called Q. It's a superset of JSON, and you can do some simple logic in that language. We use this as the implementation of the underlying code of this type, component type and trait type. We call it component definition and trait definition. It is definition in the ecosystem. So for the DevOps team, they just need to write some configuration, and they can customize their own components. Because yeah.
So for an application developer, you have one YAML for an entire application, and then a lot of the Kubernetes complexity is abstracted away by using the component and traits things. Okay, and that happens in this YAML here. Okay, so it's applications. So much Kubernetes complexity abstracted away and wrapped into components and traits, right?
Yeah. And also we also handle the environment in that application, because you can define your multiple clusters and different components. You want to apply that components to which clusters, or with different configurations. That's all
Oh.
handled in that application YAML file.
And then, okay, I'll get to the bottom of that in just a moment. So I want to by components and traits. Okay. So I'm seeing now how the DevOps people define when a component and trait is available, and then the application people consume component and trait. But then what you just said, that the environment is also in here, that sounds to me like the application developer has to worry about the environment. So I'm confused about that statement.
Actually,
how is the environment wrapped into this YAML?
Yeah, so that's the difference between the KubeVela and OEM, because OEM is only the model and KubeVela is an implementation. So while we were developing this implementation, we realized we need to add more to that model. So besides of components and traits, we also add policy and workflow in KubeVela. Yeah, so the multi-environment handle is handled in policy. And if you want to control the delivery process of application, you can write a workflow. But if you just want to make your application simple, you can just write components and trees and it will also work.
So the complexity of the environment is abstracted away by these two new abstractions you just told me about.
Yeah.
Okay. So great.
And we still want this application YAML to fully, only focus on that application, because we don't want users to know the underlying infrastructure. So I'd like to say the second benefit here is infrastructure agnostic.
Okay. What are the two abstractions you told me away that the complexity of the environment that abstracts that away? Policy was one, right? And what was the other?
Workflow.
Okay, nice. Cool. So an application developer can define their application using these abstractions: components, traits, policy, and workflow, right?
Yeah.
And it's infrastructure. They don't have to understand the underlying infrastructure.
Yeah. And that's the benefits. Yeah. That's the benefits for the application developer. And we also have one benefit for the DevOps team or the SRE. That is, you can fully all of these components, trees, policy, and workflow. It is they are programmable. They are easy to customize.
So benefits for app developer, application-centric, and infrastructure agnostic, right? And now we have benefits for the ops folks. Okay, benefits for ops. And what was that one you said? Programmable?
Yeah, programmable.
That's will you be more specific about what you mean by programmable? That's a little too broad of a word.
Yeah, so with components and trees and workflow and policy, they all have their own type, and the type points to what we call X definition. You can say it as component definition, tree definition, whatever. It's actually a custom resource in Kubernetes, and you can in that definition, you can write the template of the component or the trait. And the template is written in a configuration language called Q, CUE.
Okay.
So if you want to customize your own component type or trait type, you can just program. You can just write the code of Q codes and apply the type in the cluster, and your developers can use this type.
So you can create your own component types that your developers can use. Okay. Is that true? Well, then, okay.
I can have one specific example. We talked about the ingress version is vary from different Kubernetes clusters, right? So for that ops team, they can just write one trait type that in it actually render the resource of ingress, and with this configuration language called Q, we can write some simple conditional judgment. Like you can write some, if the cluster version is higher than 1.19, then we can use the ingress version of version 1. But if it's smaller than the 1.19, you can use the version beta 1. So that hides the complexity of infrastructure, because you can hide all them in the type definition. That is what we called.
So you can, for an example, is you can relate the ingress object to the Kubernetes version.
Yeah.
We have a comment from Eventually. They've been eyeballing Q for a while. Looks really promising. Beats the hell out of YAML. I have a question. Is Q is that an acronym for something, or is it just called Q?
I think it's configuration unify, and E stands for word. I just forget it. Anyway, configuration language. Yeah.
If someone in the chat knows it, I'd love to hear it and put it on the board, but if not, that's okay too. Oh, there it is.
Yeah.
Configure, unify, execute.
Yeah.
Okay, nice. Configure, unify, execute. Nice. So with the word execute in there, I'm feeling that you can put logic in with it too. It's not just configuration, but you can add like dynamic capabilities. Is that correct?
Actually, there's some package. You can actually import some package in that configuration, because you can like import JSON.Marshall, so that you can do some data execute and Marshall things. And actually, we're doing some more in our work that we can talk later. And for components and trees, we just use this Q language to render the resource. So in this case, we use little capability of execute, more of configure and unify.
Okay, cool. And then is it true that that the ops folks can configure components and traits and policy and workflow? Is that all responsible? Are ops folks responsible for all of that?
Okay. Yeah, and we also made a lot of best practice in the community. So so if you don't have ops team, you can just and you don't have that much capability to build your own definitions. You can just use what we have developed in the community, and we actually cover a lot of cases. So these are the best cases from the community.
Great. Oh. So in many cases, so I like that. Like sometimes you're going to have needs that are specific to your organization and sometimes you don't. And when you don't, it's good to be able just to consume what already exists.
Yeah. And it's pretty common that if you are in a very small company, because we have some users that from very small company, and the users know little about Kubernetes because he's like a front end developer, and he just use our KubeVela to do GitOps and manage uh, their configurations for different environments like the product cluster, test clusters, etc.
Cool. Traits, policy. Cool. So if it's a big company and you have complex use case, you can encode that into your own definitions. And if it's a small company and you really want to abstract away all the Kubernetes you can just rely on the community best practices.
Yeah.
Cool. Love it. So from the developer experience, what is the size of a YAML for a pretty normal application? Or even a minimal application?
Just components and traits. And with this abstraction, you cannot you cannot only have Kubernetes resources in that application. You can also combine the native resources with Helm and like Terraform resources. It can all be combined in one application thanks to this abstraction layer.
So Helm and Terraform, for example, or really, are you saying that would be included where in the application YAML?
Yeah, you can have a component called Helm, in which you can just use this Helm as a workload, and also you can have a workload a component called Terraform, and you can specify the Terraform provider you want to use in that component, so that you can just unify them all in one application if your workloads are really varied.
So you can create completely new abstractions. You're not confined to these four, is what you're saying.
Oh no. The Helm and the Terraform can be the type of component.
Oh, got it. Okay, so you can create completely new types. Okay.
If for example, if you want to, if your application is a WordPress application and you want to combine that, you want to connect to a cloud database with your WordPress, you can just have two components in your application. The first one is the type is Helm, so that you can apply a Helm called WordPress, and the second one is an RDS, so that the type may be the Terraform database, such things, so that you can have different types of components in one application.
So maybe a good thing right now, it depends on how much you'll have left to teach me, but maybe a good thing right now would be to write something like that down. Like, here's what an example application would look like, and basically capture what you just said. Does that sound good?
Okay, so if a typical application, we can write both of the four parts in one application. That is a component, trait, policy, and workflow, right?
Oops. An example application.
Yeah.
All right.
Yeah.
So we might define a component.
Yeah, components. You want to
Uh-huh.
write it in YAML, right?
Oh, I'm gonna write a YAML file. I don't think I'm gonna do that. I'll
Um,
just put YAML. Okay. I like the visual continuity of every time I mention an object, I put it in that box so you
cool.
can kind of relate it.
And
So we have a component in our example application.
yeah, and it has a type. We can call it a web service type. Web service.
Okay.
It is an official component definition in our community, and this web service type is actually applying an deployment to the cluster. And the user, and there's also
Okay.
some properties to the component, and inside the properties is what users want to have in that component.
Okay.
So if the case
Okay.
is simple enough, the users may just want to specify the image. So the properties and image like NGX.
Okay. Like an operating system image, you mean?
Yeah.
Or oh, sorry, it's a web server image. Okay.
Web service image.
Sure. Yeah.
Image NGX.
Web server.
Yeah, so actually what will happening is that in our component definition called web service, we will unify the user input that you put in the properties, and with what we predefined in that definition, unify them together and render the results called deployment.
Okay.
Yeah.
So what are some other examples of properties?
Okay, so if your component type is Helm, then the properties may be the Helm URL, the Helm value, the values, and the Helm release name, things like that.
Yeah.
What you can put in the properties is defined by the definition. In that definition, we have a field called
Okay.
parameters, and it exposes the properties to that YAML.
So for now, our example application just has a web service, and that property has a type that we want to use the Nginx image, and
Yeah.
that gets rendered into a deployment.
Yeah.
Okay. And is it a Kubernetes deployment?
Yeah, it depends on the component definition that you are using. In this case, it points to
Okay.
a deployment. Yeah.
Okay. So in our example application, we have one component that's a web service. And then do you want to make a Helm component too in our example?
I don't think the board can have another component because we also want to write trait workflows and policies. Okay, we can write trait.
Okay. Okay.
So trait, we can have a gateway type trait.
Okay. And this is official too, right?
Yeah, this is official too.
Okay. All right.
And in that trait, you can have properties like the port that you want to expose and the path of your gateway, actually service.
So a port and a path to what?
Yeah, to expose the service of the workflow, the deployment.
Okay.
Like the port
Okay.
is 80 and the path is, slash hello things. Yeah.
Uh-huh.
Okay. So in this case, we want to, like apply this NGX to multiple environment so that we can write our policy.
All right. So the component plus the trait is what gets rendered into a Kubernetes deployment?
Yeah.
No, because this is making a service. Yeah, okay. Got you.
Yeah. So the component will render a deployment, and the trait gateway will render a service.
Cool. And next up is policy.
Yeah. We can write it simple. You can have, for example, two policy. The type of policy is called topology. That is also an official policy type.
Okay.
Yeah. So the first policy, it can point it to a test environment, so that in that policy we have properties with cluster to local and namespace to test. So that means it is.
How does it point to?
It can have the all the values are right in properties.
So the pointing to the test environment is not in properties?
In properties.
That's separate.
Yeah.
It points to the test environment as one of the properties?
If you specify the cluster, in that properties, you can specify your cluster and your namespace. So you can define what is test environment in your case. So in this example, we just make it simple. The cluster is local and the namespace is test. So the local clusters means the managed cluster, the cluster that you deployed, that your KubeVela deployed.
Okay.
Yeah. And
so in our properties, we're specifying the cluster and the namespace. Anything else we're specifying in the properties?
In this case, no. And we can specify two policies because one is for test and another is for product. So the other maybe the cluster, we can still have local cluster here, and the namespace we pointed to product. That means it is the product environment.
So, and then this will get rendered into a Kubernetes admission controller?
No, it is a abstract concept. What we would do is we were going to use this policy in our workflow.
Oh.
Yeah.
Okay. So then the properties here. Also cluster, but this one would not be local. It would be, it would be local? We're just doing that?
It's up to you because, yeah.
Yeah. And then namespace. Production.
Yeah.
Cool.
Okay. And the final part is workflow, in which you can define the process of your delivery.
And okay, workflow. How much space should I do this? Yes. Okay.
Yeah, so I want to have 3 steps in workflow.
Okay.
Yeah. So the first step, the type of the step is called deploy.
Okay.
Yeah, and the properties have only one parameter called policies, in which we specify the task the properties the policy that we predefined to the test product. You know, the policy have a name.
Okay.
We emit that in the case. You can just use a line to point to the policy.
Sure. Okay, so this one, at first we want to point it at the test one?
Yeah, you can first apply the application to the test environment. So the properties have
Okay.
policies that point to test policy.
Cool.
Yeah, and we have 3 steps here. So the second step is actually a suspend step. It means that you can check some things or wait for some permissions before you really apply your application to the product environment.
So it's a suspend step?
Yeah, suspend.
Is that what you said?
Yeah, yeah.
And
This one
then
has
you would
no
perform
properties.
in the okay.
Oh, this
Perform checks.
suspend step, you can write. You don't need to write properties. Okay.
I wrote perform checks and wait. Is that
Oh,
correct?
okay, cool.
Sorry, it's
Cool.
small for you to see.
Yeah.
Is that correct? Perform checks and wait? Okay.
Yeah. And the second step is similar
Cool.
to the first step, except the policy use the product policy.
I thought the suspend was the second step.
What?
So suspend is part of the first step?
No. Suspend is the second step. I'm talking about the third step. The third step.
Okay, cool. Step 3.
Yeah, it's pretty much like the first step, except the policies point to the product policy.
Cool. And then so we apply this policy. And
Yeah.
so where's the application actually getting deployed and defined?
The application is defined in that components and trees. So the workflow only controls the process of the delivery. It separates the delivery part to different environments, but the application is defined in components and trees.
Cool. So I want to write that. Workflow Defines delivery process.
Yeah.
And then policy defines the environment.
More than just environment. How to say? The policy actually. You know. Wait a second. The policy we can have. Uh. You know, except for the environment, you can also write some garbage collection or other policies. So it's actually a set of rules that can apply to the application.
Okay.
Yeah, a set of rules, I guess.
Okay. That makes sense with the word policy. Excellent.
Yeah.
Cool.
Okay.
Making it up.
Yeah, we haven't talked about the some other concepts, and the board is actually full.
I can write over my face. I have a little room here.
Okay.
What concepts? Yeah, if you give me an overview, it helps me fit it in.
Yeah, so we have another.
But I'm not afraid to write over my face. Uh-huh.
Yeah, another concept is more like our ecosystem, because we have all this abstraction, so we have our own add-ons.
Uh-huh.
Yeah, so add-ons is actually
Okay.
when you enabling an add-on, it will first apply some resources defined in that add-on, and together with some definitions, which perfectly suit in that our application ecosystem. So, for example, we just talked about the Helm component type, right? So we are actually, if you want to use this Helm type in your application, the official way to do it is first to enable the add-on called FoxAD. Yeah.
Okay. So when we talk about add-ons, since we don't have a lot of space, like you're welcome, I would like to hear everything with the words, but I think maybe with this space, we'll just write some examples of add-ons you can add. Does that sound good?
Okay,
Like, so we can add on
you
Helm.
can just write some like command, like Vela add-on enable FoxAD.
Yeah. Instead of, well, maybe we'll call it like Flux CD integration would be an example of an add-on, right?
Yeah. So, we don't want to reinvent we in the cloud native community.
Yeah, that makes
So
sense.
we use this capability, to handle the Helm situation in our cases, and also the GitOps situation.
Cool. So those are all basically different. Yeah.
Yeah.
GitOps.
Yeah, and we have, GitOps.
Yep.
And one important add-on is Vela UX, which is our dashboard. We invite this, and we also use it as one of our ecosystem. So we call it an add-on.
Cool.
Yeah.
I assume you would have Argo CD also if we're doing GitOps.
Yeah.
And there's probably a pretty rich ecosystem of stuff, right?
Yeah, we have like more
Yeah.
than 50 add-ons in our community right now.
Ah, yes. Great. Make sure I fit. Yeah. More than 50.
Yeah.
Cool. Excellent. Any other ones you want to call out with this last little bit of space?
Not enough, though I haven't explained enough about the underlying, the extensibility of workflow. Yeah.
Cool.
Yeah. The workflow step is a little bit different from the component and treat, because you only render the resources in component and treat. But in workflow, you can do some execution. You can call some functional capability. Like so for example, actually in our workflow step definition, you can not only import the official package of Q like JSON.Marshall, you can also import some KubeVela built-in packages and use our capability.
Okay.
For example, like in that workflow step, you can not only suspend the step, deploy the components, you can also send HTTP request or delete or update the resources and send some notification, things like that.
So possible actions.
Yeah, it's more like you can call some function in every step. And this is also the biggest differences between KubeVela workflow and other workflow projects.
Okay, besides deploy and suspend, what other ones did you just talk about? Deploy, suspend, what else?
Request and actually CRUD of the resources. Yeah.
Okay.
Yeah.
CRUD. Okay. And then, so they're functions.
Yeah, they are functions, and you just need to write definitions to use that function, and it is very easy to customize. So for example, I just the ChatGPT is going viral, so I just write a step called ChatGPT last week. So in that step, I just use the capability of HTTP request to send some prompt to open the AI. And in our application, the first step can apply a resource in the cluster, and it can maybe the components have an invalid image, so the underlying resources will never be healthy. And the second step is ask the GPT to diagnose that step, the resources, to let it to see what's wrong with the resources. You can use data passing to pass the resources applied in the first step to the second step to let ChatGPT to diagnose. So with this extensibility, you can do a lot of things.
Look, I made some room for my face, kind of. I just have to stand on my tiptoes. So this is great. So the workflow is extensible and you can include functions, and being able to include checks is a really important point, because if things just go wrong and you like something may not properly deploy to environments and you don't even know without those checks in there. And it's good to know right when things aren't working before you start building on the error or trying to build on the error.
Yeah, and
so that makes a lot of sense.
Yeah, it is just we want to use workflow. It's just pretty common that you want to control all the delivery process in the application delivery. In different companies, you may have different policies. Like waiting for some approvals is quite a common case.
Mm-hmm. So it seems to me in an organization, if I'm a developer, first of all the components already exist. The component, the traits, the policy, the workflow, that already exists. And so I can just use it. But
Yeah.
then this example application is getting, so the workflow is defined by an ops person. So when I import the workflow, is it discoverable for me to know what fields I need to fill out as an application developer?
Yeah. It has
I'm
the
an application developer. Yeah.
yeah, because
How do I know which of these properties are available to me and how to use them is the question.
yeah, we have this command so that you can see every parameters that you need to fill in the type. And actually, if you are
Okay.
application developer, we have this official dashboard called Vela UX, right? So in that Vela UX, we just visualize
Mm-hmm.
everything, including what parameters that you need to write to fill in your application. So it might be a very good start.
Okay.
Yeah.
Cool. So that's benefits for app dev. Um, what's a good way of saying that in one sentence? Like discoverable.
This discoverable I don't know, discover parameters or
Resources. Yeah, I
resources.
like that. Cool. Discoverable resources / parameters.
Yeah.
So I'm an ops person. We use KubeVela. I'm able to create components and traits and workflows and policies that help my developers define their application and talk about where to deploy it and how to deploy it.
Yeah.
So I'm an ops person and I'm in control of that.
Yeah.
And then I'm a dev person and I have between this UX or a command, I have a discoverable way to see all of these building blocks that are available to me, these abstractions, and then
Yeah.
I can use them to plan out how my application is going to get built and deploy, and by abstracting away all of the infrastructure complexity of Kubernetes specifically because KubeVela is made for Kubernetes, but
Yeah.
but with the OAM model, it could be implemented in other ways that aren't necessarily for Kubernetes.
Exactly. And it's actually,
Cool.
the KubeVela is more like it's kind of like a framework that can help you to build the application platform. Although you can use it directly, but if you want to customize it can be really easy.
Framework and platform.
Yeah.
All right. If anyone has any questions, we'd love to hear them. I think we're wrapping up. Even if you have more to say, Fong, I think I don't have any room to write it. But if you want to talk about some things, you're welcome to. But if you feel like we're finished, the next step is going to be I'm going to do a recap to make sure I learned everything that you are teaching.
Cool.
Do you think it's time for a recap? Do you feel ready?
Yeah.
Yeah? Okay, cool. So, and if anyone has any questions, now is the time to get to those questions because after the recap, we'll say goodbye. So, the world before KubeVela, a lot of operational complexity, Kubernetes and otherwise, would fall on app developers. So they would not only have to understand their application specifically, but all the details of defining it and deploying it. And they might have to have deep understanding of their own infrastructure, which an app developer shouldn't need to have. They should be writing code. So there are DevOps teams that exist, and the goal of the DevOps team is for the app developers to develop and the DevOps team to do all the DevOps part. So we want to separate those concerns that we're kind of all getting wrapped up into one role or one team before. So at the base, before we even talk about KubeVela, we need to talk about the open application model, so OAM. So it's they wanted to be a standard to define an application, and it's a joint project by Alibaba and Microsoft, and started in 2020. I said a standard to define an application. I think specification to define an application is a better way to say that.
Yeah.
So with the open application model, you use a resource type called a component, and that represents a workload. And there are many types of components. So one type we talked about was a web service component, but you also talked about a Helm component, for example. There are many types. And then as part of the open application model, each component has traits. So those traits are giving extra capability or extra definition that's attached to a component. So another component example we used was a Kubernetes deployment could be a component. And then a trait of that Kubernetes component would be a replica set. And then, yes. And then can traits have children? Can there be traits of other traits? Like would the Kubernetes replica set have a deployment, a pod as a trait for that? Like a pod definition?
No, but you can have multiple traits to one component.
Many traits to one component, but traits cannot be children of each other. Got it. Yeah. Great. And then the point of this is to abstract away this complexity. So a developer can work with the workload component without fully understanding a Kubernetes deployment, for example. They just know it's discoverable to them what kind of parameters or knobs they have that they need to fill out as part of creating a component abstraction. So that's the baseline for KubeVela. KubeVela is a modern application framework and platform, and it's the official implementation of the OAM model. Well, the M is for model, the OAM on Kubernetes. So OAM itself is not specific to Kubernetes, but KubeVela is the implementation for Kubernetes. So from the app developer's point of view, you write an application-centric YAML, just one YAML for your whole entire application. And then it is discoverable all the different choices you have for what abstractions you have, the building blocks you have to create this YAML. And that discoverability is powered by you can do it in the UI, the Vela UX dashboard, which great. And so then you have one YAML to define for your entire application, and then much of the Kubernetes complexity is abstracted away by the components and by the traits. But then you can also, KubeVela specific, you can define your environment using the abstractions policy and workflow. So the policy is more about the environment, like a set of rules for the environment. The workflow is more, it sounds like the how things are getting deployed within that device. So the policy is the what, the workload's the how things are getting defined. So what's cool so these things are abstracted away from the developer so they can just consume them. And it's also infrastructure agnostic. The developer doesn't have to have any idea where it's going, like to what cluster. It can be multi-cluster, it can be hybrid, it can be all the things. And developer doesn't need to worry about it. And it sounds like even an ops person could come in the background and change a policy, and then all of a sudden it could be deployed to somewhere else, and the app developer's experience doesn't change at all. Is that correct? Yeah. They just don't have to know that part. Yeah. Great. So then putting the ops hat on, now as an ops person, I have all these abstractions I can define and then give them to my developers to use. So the abstractions are programmable, and they use the Q configuration language, which Q stands for configure, unify, execute. So there's a rich ecosystem. So a lot of component types already exist, or a lot of things already exist for all of these types: components, traits, policy, and workflow. But you can also completely create your own that's custom for your own company. So for a big company that has a lot of policy, a lot of specific procedure already in place for how things should be deployed and to where, they have a lot of control over where they're going to deploy it and how. But for a small company who doesn't necessarily have that stuff figured out yet, a small company can just lean on community best practices of what's already available and use those in that way. So, I talked about some more component. So we talked about one thing is like an ingress object might be dependent on a Kubernetes version. So you can encapsulate that connection into a component as opposed to dealing with those things separately. Great. So then we talked about, I think this is related to the ops side, is the workflow specifically. It's extensible, and because of that queue configuration language, you can put functions and dynamic capabilities into your workflow. So you can do actions like deploy, you can suspend, which is like wait and do checks. You can do HTTP requests or CRUD stuff. You can do a lot of different things, but they're functions and they can be customized for your exact use case. And that seems to fall into the ops category. So then we talked about a specific example. So an example application, now this would all be in YAML. So a developer might want a web service. So they would use a component of type web service. And then all they need to say is Nginx. And then the complexity of that is already written into the component, and it's built now into the application. Then the developer might add a trait to that component and say that they want a gateway. And then they might add in a port and then the path that they want to use. And then the developer might add a policy for how to deploy this to test. And that policy they would have to say maybe this local cluster, and they might have to specify a namespace. And then they also might have a second policy for deploying to production, where they would say which cluster is their production cluster and which namespace they would want to use there. So then once they define all those things can be used in a workflow. And the workflow is already defined by ops. So the workflow might go something like, step 1, deploy it into test. And step 2, suspend it, perform checks, wait. And then if those checks pass, then step 3, deploy it to production. So that's a sample of what might happen in a workflow, a very simple workflow. So in addition to all this, there's a ton of add-ons. So there's integration for more than, it sounds like 50 different other CNCF or other cloud-related tools. So we really leaned into the GitOps tools. So GitOps, Argo CD, Flux CD integration, also Helm integration, also that cool dashboard that helps developers know what fields, what abstractions they have to work with and what fields go within those abstraction. That's all within the add-ons. So there are more than 50 of those. Yeah. And I think that's everything. How do you feel about that?
It's pretty clear.
You feel good?
Yeah, you understand the concept. Yeah. You are now a KubeVela expert, maybe.
Excellent. Only because you're a KubeVela expert and you're a very good teacher. So I appreciate that. That's amazing. This has been a really fun episode. Is there anything you want to say before we dance it out?
I just want to point out a small mistake. The ingress.
Oh yeah.
The example that we just used, ingress, is actually a trait because it's not a workload, right? So it's a trait example.
Okay.
Yeah. Great.
I love it. Good. Okay. Example traits, relate ingress object to the Kubernetes version. Cool. Let's give some love to y'all in chats. We're going to need a bigger board. It's true. I think this is the most I've ever painted myself in a corner before. Lisa says, super job, Bog. So thank you so much. I agree with Lisa. And eventually says certification inbounds in relation to being KubeVela experts. We're all KubeVela experts now.
Yeah. All of the
time
KubeVela experts now.
I love it. Let's give Enlightning certifications. All right, let's dance it out. Goodbye, everyone. Thank you so much for being here. I appreciate you. Ready? Yeah. Just turn your wave into a dance.
Okay.
There you go. Bye.
Bye. Thank you, everyone.